If you're like most sapient carbon-based life forms in the juvenile to adolescent stage of their development, then I'm guessing you don't spend a lot of time thinking about triangles. At least not on a daily basis, and that's fair. Triangles probably don't spend a lot of time thinking about you. But when the two circles converge on your DSAT official exam day, it might feel a little daunting seeing all the triangles show up in the geometry and trigonometry section. Don't worry, that's what we're here to do. We're going to go over as much of the triangle information as you should require to ace this portion of your upcoming DSAT math. All right, I'm Will with Principia Tutors and Consultants. Let's jump right into it. So, quick recap about triangles. When it comes to perimeter, you add up all the sides. If it's an equilateral triangle, you can just multiply one side by 3 because equilateral triangles, all sides are equivalent. The area of a triangle is 1/2 BH as we've been taught, so hold on to that knowledge. Now, if it's an equilateral triangle, you can use 0.25 times the product of s squared and the square root of 3, or s squared root 3 over 4 to solve for that area. When you're working with right triangles, just remember the following. You can use the Pythagorean theorem to find the third undefined side as long as the other two sides are defined. So that's the whole a squared plus b squared is c squared, or c would be the square root of the sum of a squared and b squared. C here is denoting the hypotenuse, so that's the longest side of the right triangle. A and B would denote the other legs. If you see a box or a square in the bottom corner of the triangle, that's a way of denoting it as a right triangle. Look for it, otherwise you can't be confident that it is, unless of course the question says it's a 90-degree angle or specifically identifies it as a right triangle. And again, remember the hypotenuse is the longest side of the right triangle. Okay, so there are some special integer right triangles that'll be helpful to know. 3 of them would be the 3, 4, 5 right triangle, where 5 would represent the hypotenuse, 3 and 4 would be the other legs. The 6, 8, 10 relationship and the 9, 12, 15 relationship are all good to know. And so this is what they can look like if drawn out. All right, the other 3 that you may see pop up are the 5, 12, 13 right triangle, the 8, 15, 17 right triangle, and the 7, 24, 25 right triangle. Remember, the largest value represents the hypotenuse, and so as long as you're given 2 of the values, you can easily get to the third by memorizing these relationships. All right, quick trig recap. Let's go over SOH CAH TOA. So sine is equal to the opposite over the hypotenuse. Ka, that would be cosine is adjacent over hypotenuse, and TOA is tangent is the opposite over adjacent, or the sine over the cosine. So with this given example right triangle, we have a 5 and a 12, so hearkening back to those integer right triangles, I know the hypotenuse here is 13. Now I can put in all the trig values. So the sine of x would be 5 over 13, opposite over hypotenuse. We'll notice that that is the exact same value as the cosine of y. If we look at the cosine of x, adjacent over hypotenuse, 12 over 13, again, that's equivalent to the sine of y. Then finally, tangent of x, opposite over adjacent, would be 5, 12. Tangent y would be 12 fifths. So we can see that the tangents of x and y are reciprocals of one another. So some things to notice and just pay close attention to help you with memorizing these relationships. As we mentioned before, sine of x is cosine of y, sine of y is cosine of x. The tangents of x and y are reciprocals of one another. What does this mean? So since we're dealing with a right triangle, x plus y must equal 90 degrees because we know the right angle accounts for the other 90, and the sum of the interior angles of any triangle is 180 degrees. So this would mean that sine of x is cosine of 90 minus x, and cosine of x is sine of 90 minus x. Hold on to that piece of information as opposed to just thinking that the sine of x would be equal to the cosine of x. That's not always going to be true. These relationships would hold under any circumstance given a right triangle. All right, some special right triangles. So there are 2 that you're going to benefit from memorizing. So pay close attention to the slides. Feel free to pause them and take more detailed notes at whatever pace works for you. So 45, 45 right triangles, 45, 45, 90 right triangles are the first of these. They're isosceles right triangles, and so the 2 legs, the base and the height, are congruent as evidenced here in the figure. Now I know I've been using S to denote side, but these A's do the same thing. So don't get too hung up on variables if you see something different than the s's that have been showing up in my examples. And then finally, the hypotenuse is the side length multiplied by the square root of 2. And so how do we find the perimeter of the area? Well, if we know the perimeter is the sum of the sides, that's going to give us 2s plus s root 2. Or if you're looking at this example, that would just be 2a plus a root 2. And the area, since it's 1/2 base times height, that would be 1/2 of side squared, because base here and height are equivalent. And so for this example triangle, it would be 1/2 a squared. All right, so the other special right triangle is the 30, 60, 90 right triangle. And since they're scalene, we can't just assume that the base and height are equivalent. They should be different values that would identify them as scalene. The hypotenuse is going to be twice the length of the shortest side. So in this example here, that 2a, because the shortest side is denoted by a, it's the one opposite the 30-degree angle. And so that's another way of knowing where your smallest side is going to be. It's going to be opposite the smallest angle. The longer side is going to be a times the square root of 3. So the perimeter here is going to be the sum of all the sides, so 3a plus a square root of 3, or 3s plus s square root of 3 as denoted in the notes. And then the area, because it's 1/2 base times height, it's going to be 1/2 the side squared times root 3, or if we're using this example model, it'd be 1/2 a squared square root of 3. All right, so as we go through these examples, I'd like you to take a look at each of them, pause the video, try to solve it on your own, and then we'll go over it together. So pause the video, take a couple seconds, we'll pick up soon. All right, so since this is a starting example, I've denoted where the s's and s root 2 are, just as a friendly reminder, and we're working with a 45, 45, 90. And since we have the s root 2 hypotenuse defined, we need to find the value of s so we can get to our perimeter. So the way to do that, we need to take 22 feet and divide that by the square root of 2. So working it all out, making sure we resolve the root in our denominator, we end up with 11 times the square root of 2 equals s. And since the s's are equivalent here, they would account for both of those legs. So now we can find the perimeter by doing 2s plus s root 2. And so you have multiplying the 2, distributing it, you get 22 root 2 plus 22 feet. And then the area, since that would just be 1/2 of side squared, we multiply all that through, we'd end up with 1/2, 121 times 2. So the 1/2 and the 2 would cancel out, leaving us with 121 feet squared. So pay attention to the units. It's not entirely common for a question to give you the wrong unit for your answer, but it's always good just to pay attention in case. All right, for this next one, I've not defined where all the s's and s root 2's are, but you can use the previous example to help you with it. Now I want you to find the sine, cosine, and tangent for angle x for this triangle. So go ahead, pause the video, take a few seconds to try it on your own, and then we'll work through it together. All right, so if I recognize this mark letting us know that these would be congruent or equal sides, then I know their respective angles would be equal. Wonderful news. And that also would mean that this right here is also going to be 5 root 6 because it's the same as s. So I haven't defined what s root 2 is, which would go here for the hypotenuse, so I need to do that. And so s root 2 would just be 5 square root of 6 times square root of 2, which is 5 root 12. Remember, you can partition that into root 4 times root 3, and that would resolve to 5 times 2 times square root of 3, leaving us with 10 root 3 as our s root 2. Try saying that 5 times fast. All right, now if we want to find the sine, just remember it's the sine of this x. We've confirmed it's a 45, 45, 90-degree triangle. And so the sine of 45 opposite over hypotenuse, 5 root 6 over 10 root 3, making sure we resolve our radicals in the denominator, and it'll come out to square root of 2 over 2. What we'll see with the cosine of x in this instance, when x is 45 degrees, we get the same answer as we would with the sine, because the adjacent over hypotenuse is going to be the same value relationship. So it can help to remember that the sine of x equals the cosine of x when x is 45 degrees. So it's not always true, but it holds in this instance. And finally, the tangent, that would be opposite over adjacent, and since the opposite and adjacent are equal, anything divided by itself comes out as 1. Let's try 2 more. All right, so first go through the perimeter and area of this triangle. Again, courtesy, labeled these values so you have a quick refresher. So S for the shortest side, S root 3 for the longer side, and then the longest side, or the hypotenuse, as 2S. All right, take some time, try it on your own. We'll pick up soon. Alrighty, so I can find 2S just by doubling 31 and end up with 2S is 62, so that's my hypotenuse. And then if I know that it's just S root 3, just do 31 root 3 for the longer side. And so I have all the points defined, so now I can find the perimeter and area of this triangle. We know that the perimeter of a 30, 60, 90 is 3S plus S root 3. That would come out to 93 plus 31 square root 3 inches. And finally, since the area is 1/2 base times height, or in this instance, 1/2 S squared times the square root of 3, working that all out, you'd end up with 961 times the square root of 3 over 2 inches squared. And so you could leave your answer like that. You won't encounter a grid in like this, obviously, but if you end up with a multiple choice, it could very much look something like that. All right, let's go over this next one. Now I want you to find the sine, cosine, and tangent for both the 30 and 60 degree angles of this triangle. And right now, I've only defined one of the sides. So take a moment, pause the video, try it on your own, and we'll pick up in a couple seconds. So since I've defined the side that corresponds with the 60 degree angle, this is the S root 3 side. So I need to divide it by the square root of 3 to find little s for the shortest side, and then I can double that to get the hypotenuse. So first and foremost, you take 3 root 5, divide that by the square root of 3. We'd end up with 3 root 15 divided by 3, which will simplify to the square root of 15. So with that as our s value, the 2s for the hypotenuse is just 2 times the square root of 15. Moving on, the sine of 30 degrees, since we've gone over that sine of x is equal to cosine of 90 minus x, I can say sine of 30 equals cosine of 60, and I can start crossing things off as I solve. And so here, since sine of 30 is root 15 over 2 root 15, that would come out to 1/2, which is the same as cosine of 60. Is cosine 60 adjacent over hypotenuse? We're seeing that same relationship. And so if you can see where this is going, the sine of 60 then would be the cosine of 30. And so if I solve sine of 60, 3 root 5 over 2 root 15, which would just be the cosine of 30, because that's the adjacent over the hypotenuse in that instance. Working everything out, resolving the radicals in the denominator, yields a square root of 3 over 2. And then the tangent, what's helpful here, since we know the tangents are reciprocals of one another, if I solve for the tangent of 30 degrees, I can just take 1 over that value to get the tangent of 60 degrees. So solving for the tangent of 30, we've got sine of 30 divided by cosine of 30. Since we've already solved for these, so sine of 30 being 1/2 and cosine of 30 being square root of 3 over 2, we resolve all this and we end up with 1 over the square root of 3, which after resolving your radical in the denominator is the square root of 3 over 3. We've talked about how to find tangent of 60. It's just 1 over the tangent of 30. And so you just take the reciprocal. And so the reciprocal in this instance would be 3 over root 3, or the square root of 3 over 1 after you resolve it. All right, now let's recap our triangle problem strategies. So first thing to remember, the perimeter of any triangle is the sum of its sides. The area of any triangle is 1/2 base times height. With right triangles, remember to use the Pythagorean theorem. C squared equals A squared plus B squared. Remember SOH CAH TOA when solving for the sine, cosine, tangent. Remember that sine of x would be cosine of y, cosine x sine y. Tangent of x is the reciprocal of tangent y. Some more things to note, like we brought up earlier. Sine of 45 degrees is equal to the cosine of 45 degrees. That's square root of 2 over 2, and the tangent of 45 degrees is equal to 1. The sine of 30 degrees is equal to the cosine of 60 degrees. That's 1/2. and the tangent of 30 degrees is root 3 over 3. The sine of 60 degrees is the equivalent of the cosine of 30 degrees, which is square root of 3 over 2. The tangent of 60 degrees is just the square root of 3. For 45, 45, 90 right triangles, remember the perimeter is 2s plus s root 2. The area is 1/2 s squared. And for 30, 60, 90 right triangles, perimeter is 3s plus s root 3. Area is 1/2 s squared times the square root of 3. And remember to take time to review and memorize the integer right triangles. All right, that's everything. Thanks so much for watching. Hoping you're feeling more confident about tackling this stuff when you see it on your official DSAT. And if you happen to be feeling more confident, please like, comment, subscribe to the channel, share the video with a friend, and be sure to check out our other DSAT videos in the playlist. With that, I'm Will with Principia Tutors and Consultants, and that's all I've got.